I'm Bobby. I work with Industrial Electric Motors. Today we're talking about EASA accreditation, talking about machine work and the quality of production. Today we're going to go right into machine work, or machine fit, so to say. We are accredited. We get all our micrometry outside and inside mics calibrated, so we know what we're measuring is precise and with precision. Here's an instance for a rotor that has improper machine work, or cause a failure. Machine fits could be too big and they tend to gald on each other, causing the bearing to fail, the body to rub inside the stator core, and obviously you can tell the difference between improper fits, I would say, compared to proper fits. You can tell it's pretty clean, and so we take that precaution of going through it all, making sure our fits are the proper size, and then making sure we have good runouts on each end of the shaft. From there, we compare it to our AR 100s and kind of go by that standard. So that way we know that on our end that we are doing our proper procedures of going through the whole process, and making sure on our end that what we see in the cause of failure of the motor is the cause either from a machine fit or any type of misalignment, application failures, etc., stuff like that. So that's kind of eliminating the process of elimination of what was the cause of failure on the motor side itself. For an instance, this right here, you can tell all the gald marks on the bearing fit. You can see all the golden metal from it being caused by improper load or oversized bearing fit or undersized bearing fit, causing spun bearing or expansion in the bearing itself, and excessive heat caused it to weld itself together with the bearing race to the shaft, causing it to fail. Here, for instance, I'll measure that. When I do measure my fits, I go by the EASA accredited the bearing fits and tolerance sheets, especially on depending what type of application that we're assessing. In this case, this is a horizontal, so bearing fits and tolerance is a lot tighter. So it has to be precise within the spec. Anything bigger, shorten the lifespan of the motor itself. So when we're precise with our measurements, it helps the longevity of the life of the motor itself. After all machine work, I do a dynamic balancing on this station right here, and that helps us eliminate vibration. That's one of the things of causes a failure is excessive vibration, and causes the lifespan of the motor itself and the longevity of the bearing. So after we disassemble the motor, we do the surge test, kind of confirm that the motor's not blowing up or any type of turn short. And then we take it back here, we do our full steam, hot seat, clean out all the debris, grease, contamination, any type of product. And then we put them in our ovens, making sure they're washed and dried properly. And then we go back, we surge it again, and then when they surge good the second time, we make sure to do what we call a recondition the motor. So we'll take these stators and we'll dip it in our varnish tank that creates some type of like a heavy coating almost to protect all the copper and insulation all around. And as you can see, it's very shiny, and this has already been dipped. So after we dipped it, we pretty much do another control bake and make sure the varnish is cured properly. All the parts are clean properly, all the contamination that's out of the end bells, out of the stator. This is the stator that's have been dipped, cured, baked, and scraped and bored. And then when we fully get all the parts clean and fully prepped for assembly, this is kind of one of the finished products, what it looks like. And right here is getting ready to do proper adjustments on the down thrusts for the pump load, cooling tubes to help cool down top bearings, This is actually a new installation rewind. So we do all our own lead repairs and painting and getting ready to test run and then paint and out the door. The reason why we go a little bit overboard with ours is because we know what our motors are capable of. We pretty much go above and beyond with horsepowers. That way they're more than strong enough to carry the pump load that it's designed for, because we know how it is, especially with downtime, especially in factories and agriculture.